It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance, where we remind everybody, don't bite your friends. My name is Brian Wilson, and as always, I have with me my co-host, Andy Grabner. Hello, Andy Grabner. How are you? Have you bitten a friend lately?
Not lately, but I was actually wondering, how do you define a friend then? Like, do you just change the definition of a friend in case you bite somebody? Because then they're no longer your friend, potentially.
Well, I would say you have friends and fiends, and the difference is an R. So fiend is okay.
Okay.
Friend, not okay. It doesn't matter the definition. As long as how about you can bite your fiends and that's it.
Okay. Well, I never heard the word fiends before, so I learned
a fiend is like
new.
an evil villain.
Okay.
The fiend, you fiend.
Ah. Yeah. So the good news is, I think we have a friend on the call today.
I think we do too. Not a fiend. I will not bite our guest.
Yeah, and he actually just came off of an observability clinic recording with me, where he enlightened me on the 7 SLOs to start your day, which was really kind of cool. Like not only to start your day, but in general, 7 SLOs you need to consider and build. And he actually showed us how to build it. This is, I think, a discussion for another day. But today we have Brian Chandler on the call. Hello, Brian.
Hey, Brian.
Hello. How's it going? Good to see you guys, or listen to your voices.
Well, you can see us.
It's been a while.
You can see us. Don't pretend like we don't see each other.
Okay. So it's not a secret to the people then. We can actually.
And we know you hear our voices every night because you go to sleep listening to our podcast.
That's exactly. Yeah, you just have that sultry voice. I mean, that is my habit. Like I that's how I go to sleep. I got like 4 different copies of this little tiny earbuds that I use. I cycle through them. I got a hot click button on Amazon to rebuy them every 3 months. So that's my that's what I do. Anyway,
guests that we invite. So Brian Chandler, for those people that don't know you and that want to differentiate you not only by your last name with the other Brian, who are you? What do you do? Why do you think you're here?
Yeah, I don't know. You dragged me in here. No, I'm just kidding. No, it's good. Super awesome to be here. I'm a solutions architect for Dynatrace. I cover the Southeast United States. So I work with all of our customers really, and kind of their most challenging problems out there. Different verticals. Could be healthcare. Financial, before my time here, I actually was a systems engineer at Raymond James Financial down in Tampa, Florida, there. So, and I've also worked at Volkswagen of America up in Detroit, Michigan, as well as kind of a performance analyst. And, I'm just here to share all my knowledge or lack thereof, or whatever you guys decide it is. I don't know. I guess I have to see if you think it's entertaining or educational. Yeah,
well, I think when we had a chat, right, we just didn't drag you because you had made a compelling case about some stories.
I did, yes.
Yeah, we talked about cloud migration, and we talked about things that can go wrong in cloud migrations. And you said, well, I have a couple of stories, and then we discussed. And I think we at least want to talk about 2 of the stories that you have learned firsthand, and because I think it's relevant for everyone out there that is moving to the cloud or is providing services to other cloud vendors through an API, because you want to make sure you're not messing up. Right?
Yep.
And so this is lessons learned from shifting to the cloud. Is that what this is? Right. I know I've read the notes a little bit, but just to summarize, you kind of said it all. Yeah.
Yes, and then some. No, yeah, and there's definitely, you're spot on, Andy. I mean, the reason why I wanted to come here today is just because I'm really seeing, you see all the stuff in the news and the buzzwords and the new phrases that are coming out in the IT space, and they're always talking about all the pitfalls you run into. But frankly, I still see a lot of really common, pitfalls and stuff that are easily addressable, especially for say cloud migrations, which folks are still doing, organizations are still doing. And then also I got a different story it's slightly similar I wanted to get into, but was more around kind of SLA, SLO focus, because that's kind of where another kind of buzz phrase and big trend in the market is organizations are starting to build out SRE practices, site reliability engineering practices. And I just thought I had a really, really good story around actually one of the most popular apps out there, Uber, that I wanted to talk about. So yeah, we can dive right in. What do you guys think?
Yeah, let's do it. Let's do the cloud migration first. Yeah.
Yeah. So, in the US, and this might be a total foreign thing to you, Andy, but Americans have to pay for their healthcare. And there's this thing, as crazy as that is, there's this thing called open enrollment that most healthcare organizations have to go through over here. And that's basically, it's a 2-month or a 1-month, window where all the benefits providers will basically open up their doors, and me and Brian Wilson will go in and pick which healthcare plan we want and all that, and then we're locked in, and then that's it for the year, and then next year we'll do it again. So that whole process, open enrollment, is basically like a Black Friday for the healthcare industry. So, but the thing is here is it lasts like a long time, not just one day, obviously. So it's super important. A lot of organizations will put like, a complete code freeze in. They'll have like a red line in the sand for, when changes need to be done. In this case, it was this healthcare software provider that basically builds the application that folks will go into during open enrollment to pick their benefit plans. Now they build this software, and basically their customers are the major healthcare providers, and they'll basically just change up the UI, and to the customer, the end user, me and Brian Wilson, it'll look like it was, healthcare insurance company ABC, but in reality, the people that built the software is this healthcare software company that I was working with here. So this was super important. They were actually trying to move that legacy stack, which is basically sitting in a brick building somewhere in their private data center on bare metal servers, who knows where. And they were trying to take that and shift it up to Google Cloud, right? So they kind of made an organizational decision to then basically say, okay, we're going to take this and lift and shift it. That's kind of a thing that you guys have probably heard before. That's hey, let's just take this app and stick it in the cloud and see how it runs. Never heard of anybody doing that. Yes, exactly. It's it always succeeds, right? So
yeah.
So this is what they were going to do. And, on paper, it might seem fine. You go through the compute catalog of these different public cloud providers. And you'll say, okay, well, we're running a 2-core server out in the data center here, and with 4 gigs or whatever their specs are, let's just spin those up in the cloud and then copy paste the entire stack into the cloud there, and it'll just run fine, right? Well, what they ended up doing was they took half their application, so the front end, which is written in PHP legacy code on basically just Linux servers. And then they took that and stuck that in the cloud. And their phase 1 was going to be, okay, we're only going to put the front end up in the cloud, but we're going to keep our mainframe and DB2 and legacy IIB services down in our brick and mortar data center. What could go wrong?
Yeah.
So,
and I guess just one question here.
Yeah.
Maybe somebody told them on the web performance side, you need to bring your web performance, your web generating things closer to the end user. And maybe that's a good idea why you want to start with this as well, because you will immediately get some benefits.
Yes.
And I just need to add too that it's funny you said legacy PHP, because how long has PHP really been around? I mean, I know what you're saying, but it's still funny in the fast-paced world of technology and languages. We can say legacy PHP, and just struck me.
No, good point. No, that's a great point, actually. So they take that web front end, put it up there, and you're right, Andy. Sure, maybe the first page gets loaded, but what you don't realize is that these systems that are built over the course of how many decades of whoever was involved, they become very, very complex. And there's 20, 30, 50, hundreds of services and dependencies that are built into these applications over time. And basically, they only took half of those services and put them up there. And then, as I'm sure you guys are aware, a complex transaction, especially something that's trying to deal with a bunch of medical records and things like that, and benefit plans, it's probably bouncing off of many different services. And half those services are still sitting in a brick and mortar data center across on the other side of the country. So if you think about it, when it comes down to it, they basically took an application stack where it was sitting in a room and the two services were sitting 5 feet away from each other. And they had a direct line, across the network to the next server, or the mainframe, or the DB2, and they basically put them on Mars, the front end, essentially. So every time now, the front end needs to go talk to their old school, mainframe, DB2, IIB services. It's going across the WAN, connecting through the public cloud network out to some ISP, going across the country every time it goes over there. Now, maybe it's kind of fast, right? You would think if for every transaction, meaning if a user loads a page, if for every time a user loads a page, it only has to connect across the WAN, one time per transaction. If it's a little bit slower, maybe it's not a huge deal. But therein lies the problem. And what they didn't realize was the amount of times these services interact with each other every time a page loads. So the first major pitfall that they ran into here was they basically, and I took some notes here because, I'm a note taker guy. I learned how to do this in school. So basically what you're going to see here is their PHP app, which was sitting up in the cloud, was connecting on average 10 separate times, creating a new HTTP, TCP handshake across the WAN to their IIB services in the back end. And then, so what that did, and it called it sequentially too. So if you think about it, you had the PHP code executing in the public cloud, and it needed to go get a record or something, right? So it would go say, hey, data center, brick and mortar data center on the other side of the country, I need to talk to you for a second. Go get me this, record, or go get me this benefit plan. Let's do some transactional stuff. Let's go back. And then the transaction, transaction with the transaction would return to the PHP in the cloud, and they'd say, okay, that's great. We got one record. Now we got to go get 10 more. Let's go talk to that data center across the other side of the country again and see what's going on. So it's known as kind of in the performance space. And you see this a lot with services talking with databases, the N+1 problem, where you're basically doing a very simple operation, the same operation over and over and over again, where you probably should have architected it to where it just did one operation and got multiple records. So that's in essence what's happening here. Now, again, just the pitfall here is that could be dealt with the way that was designed when these servers were sitting 5 feet away from each other on bare metal services or servers, right? But as soon as you split those two tiers apart and put one on the other side of the country, having to connect across the WAN every time it wants to grab one of these records, well, that's when you start having a problem. So basically, what we noticed was that this PHP code, it was taking 15, 20 seconds for a page to load, whereas when it was in their, legacy data center, it was taking 5 seconds, right? Because now, instead of having that super quick connection, it's just going to go across. So when we were talking about these things to the team there, they basically just said, okay, we need to take a step back, crack open this PHP code if we're going to keep that backend in our brick and mortar. And we need to make these asynchronous calls, meaning that it's not going to go back and forth every time it needs a record across the WAN. We're going to try to make these asynchronous so they either does them all at once, or we refactor the PHP code so it combines these duplicate calls into one. So that was just a major thing that we found. And, it's just kind of something you don't realize kind of when you're shifting to the cloud there. But I don't know. You see that a lot there. I got one other thing there, but what do you guys think? I mean, am I crazy here, or is it
I got two thoughts on that, but I'll let Andy go first because he's usually smarter than me.
I'm not smarter than you, but I think we think about the same thing because we've been talking about this for so many years. These patterns that we see, and obviously these patterns have less of an impact. When you are, as you explained, in the same network. Or B, if you don't have the right set of data, which means if you have test data and it's very small, and then you're surprised if the first time you're having production data and then it hits you. The sad thing about this, obviously, is that these things can be found even in development environments, because detecting something like the N+1 query problem is doable with a single user and with a very small environment where you have 2 data records in the database, right? And so, and then maybe one other thought, you said, changing the front end to an asynchronous processing model. I think what I would suggest is, this is what I see a lot, is kind of providing batch APIs, or really analyzing how the front end, how a consumer is consuming a certain service, and then based on these patterns, then design correctly your API. And in this case, it sounds like a batching. Whether then you call it asynchronously or synchronously, I think is then a second decision to make. I think the batching will make the biggest impact in this case. Yeah.
Yeah. Well, here are my thoughts on it. I had two, and I actually wrote them down for the first time ever. I took notes too, Brian Chandler, because I was taught that too. The first one is, Andy, you brought up the benefit of the doubt idea of maybe it was they wanted to put it to the web interface in the cloud to get it closer to the customers. So the first thing I would say is, as you're doing that pre-release, you need to test what that latency is when it's all in your data center, so you know what that latency is. What are your furthest customers? What's that hit going to be? So that now when you move that to the cloud, you can measure the hit between the web and the back end and see if you're losing that trade-off. Yeah, maybe you get it to the front-end customers, but maybe that was only 2 seconds, whereas if you separate it, you add 5 seconds. So total 3, bad idea. You can just kill that then and there. So having the data points of why you're going to do this and what you're hoping to gain from that, and then measuring those data points and verifying that you're going to get that gain is key number one. And number two, the first thing I thought about when you talked about all those calls going from the data from the cloud back to the data center is that's public network. That's higher costs and fees, right? So are you saving money by making that choice and making that move? Because I believe still, correct me if I'm wrong, I know back in the earlier days of clouds, if you go public network, that's where you're getting the network charges. Is that still true? Or
There's some egress charges, I believe, still. Yeah, that's another really good consideration there.
So we always talk about the cost of your performance, right? Are you making it more expensive, or are you making it save money? And to Andy's point, if you batch those and make one call, yeah, you're still going to have a data transmission, but it's going to be a lot less because you're not doing it individual calls. So things to look out for when you're making these moves. And as Andy says, this can all be done in that shift left mindset, in that let's get it up in the dev environment, see what's going on, and then make an evaluation to say, this is a good idea or this is not going to work the way we're doing it. Right?
And maybe one thing to prepare for things like this, I think what would be public knowledge is what's the latency right now and what's the latency going to be between the cloud provider and your data center. So let's say the latency used to be 1 millisecond. I'm making a number up now. It's 50 milliseconds. You can use chaos engineering. You can use any type of software that is artificially slowing down or imposing latency in your local network. So you can already test this. How does the system behavior change if you all of a sudden have a 50x latency between two servers?
Great point.
Absolutely. And you just funny, because Brian, you mentioned data points and how important they are. Yeah. One of the things that really opened their eyes to this was, I created a report for them showing, because they kept one of their environments, a version of their stack wholly in the brick and mortar data center. And then they did the hybrid one, which was the front end in public cloud and then brick and mortar. And it was just a simple chart showing every time you're making one of these calls, just from network time alone, it's a 10x difference. So it went from like something like 20 milliseconds time on the brick and mortar in network time. And that's not even the compute time. That's just two entities trying to start to talk to each other, right? When you shifted it to the cloud, it was like 200 milliseconds. Every time a cloud resource was coming down to even begin to do something with the on-prem. And when that thing, you add that up 20, 30 times, it's a huge difference in seconds that you end up just adding in network time. So, having good data points to use in those situations is a good thing. And I just wanted to point that out. And then,
I want to ask you one last question. Oh, sorry. Yeah. I was going to ask you one last question on that setup was, all that stuff that you did, was that before they went to production or was this after production?
This was Well, that's funny. Now we're getting into the dirty laundry part of it because it's.
All I was going to say is it was before production, then congratulations to them.
Yeah, well, it was. Let's say before our engagement there. So
Okay.
like their project was actually delayed for a little bit because of this, because they couldn't find it, and that's kind of when we started engaging and kind of showing them these data points, because it's one thing to kind of whiteboard in theory what it's going to look like, and that's what they did. They didn't have that data. I guess maybe to more directly answer your question, they kind of read the specs of the public cloud doc and said, oh, okay, here's a server that's going to have this much, disk performance and this much, network performance across the WAN. But then when actually rubber met the road, it didn't turn out very well. And that's when they started realizing these things. But yeah, they're actually this current status is that they're not actually in production per se yet, but they're trying to get there before the next open enrollment period, which is going to be this coming fall. In fact, with these findings, what they're finding is that they gotta you can't take a mainframe and put it up in the cloud. So now they've realized they basically are going to rewrite their middleware services that talk to DB2, the mainframe stuff, and just rewrite it in Spring Boot and have that run in the cloud next.
Aren't there some mainframe cloud offerings now? I thought someone had one. Not that I'm saying they should do that, but I thought someone's trying to do something. Anyhow, it's a different topic.
Does it come with like balloons that'll help float it up there? Is that
exactly
like?
So Brian, you said there's another thing.
Oh no, those are the two. The calls of the public network calls, and then the latency.
There was one other thing that's kind of
Brian.
Yeah.
Easy, Brian Chandler.
keeping ourselves on our toes here. There was one other thing in that area which I thought, so Redis, so they had a caching mechanism as well that they shifted up to the cloud, and I thought this was more of a subtle problem. Where they would actually have this Apache PHP front end caching a bunch of resources on a Redis instance, which they actually took up into the cloud as well. So you would think that wouldn't be problematic. Well, we even measured a difference when Redis, PHP talking to Redis, both on-premise, on bare metal service versus PHP to Redis when they're both in the cloud. Because when you think about it, in the public cloud, there's even layers of abstraction there from a networking perspective, even when two servers are talking to each other within the cloud. So we even found that PHP talking to Redis, every time PHP went out to Redis, and that was also sequential, that added about like 10 microseconds to 1 millisecond, a difference per Redis call. But the kicker here is PHP was calling Redis literally thousands of times per transaction. So you take that multiple millisecond, 100 millisecond, sometimes addition per Redis call, you're adding seconds onto the transaction just by nature of the networking infrastructure in the public cloud versus, kind of a bare metal situation in your own data center. Because if you think about it, they have virtual kind of network definitions in the cloud. So it has to go through kind of extra handshakes, even when servers are just trying to talk to each other within the cloud. So I thought that was really interesting as well. And there, what they decided was, we got to make sure that we optimize how this thing is talking to Redis, right? What kind of resources we're caching and how often it goes out there. It just goes to show that how much, design things, I don't want to say almost can be covered up, because it's, not to say that not to say they had a bad design. If it was performant in one environment, who's to say it's a bad design? It's just that you have to take into consideration what your design will look like and the implications of change in the environment on a design that worked in another environment. So I just thought that was another interesting kind of point there. But
I would still say there's no excuse for that design. Regardless of where it runs, right? In the end, it's not efficient, and you were just lucky that it was never found that it's not efficient.
Yeah. Well, the good thing is that just like when you move, we've all moved, right? In the past, that's when you go through and discover all this garbage you've had, and you start cleaning house and there's piles of stuff. And you're like, why was I even saving this? What was I thinking with this stuff? And this is a similar case. They're moving, they're shifting, and all this garbage is found. And when you go through those exercises, it's a great opportunity to really look at what's going on in your code and say, all right, we've survived somehow with this. That pile's been sitting over there, but now that I'm moving, let's go through that and see what the heck it's doing and see what I really need. Similar. Absolutely. Yeah.
Cool.
Hey, Brian.
Well, thank you for letting me vent. I feel like weight off my shoulders. Like it was a big thing I just need to share with you guys because these types of problems. It's like sometimes you don't run into kindred people that understand, and it's good to be on here to kind of talk about it.
Yeah. It's good, and it also feels good for us because we are. On the one side, I'm sad that the same problem patterns are still out there. On the other side, I also know that Brian Wilson and I were still relevant when we talk about these patterns because they're still out there. But talking about relevant, I think you have a second topic as well.
Yeah,
I do. Uber. I would like to hear about this.
Yes, that little app called Uber. I don't know. Have you guys heard of that one? It's like
I think Andy heard of Uber.
Uber. Yeah. It's really the fun thing that they are castrating a German word because I think it comes from Über, which means above, and they just remove the two dots, the umlaut dots. But I might be completely wrong here. But so good.
I mean, Americans have a thing for just taking something and messing it up, and just kind of making it our own. So it's like part of our thing.
Appropriation, right?
Yeah. So basically, this one I thought was really cool and kind of relevant in the space of SRE and the importance of, defining service level objectives in general, right? So one of the big problems in the performance space, I've always, and you guys might know this too, is that in a lot of organizations, it's so nebulous and arbitrary as what counts as a performance system. So I have lost count of how many projects I have helped with application rollouts where either the project manager or the GM, and they'll have like monitoring or performance as a checkbox on an Excel spreadsheet, and that'll be it. And then they'll turn to me or the performance team and say, "Hey, is monitoring good? Is performance good? Are we good on that? Do we have the dash?" And you say, "Yes, the performance is good," and they just want the checkbox checked, and then there's no criteria of what is good, and then what happens is you have a dashboard maybe in a NOC somewhere where there's a bunch of charts and graphs and lines going up and down, and nobody knows what you're measuring, and line go up bad is kind of what people end up relegating themselves to, and it's really arbitrary, and you don't even know what the impact is. So this example I thought was a really cool use case around Uber, where Uber doesn't mess around. They have put a line in the sand as to what is a performance service for their partners. So there is a program, I think it's a regional rollout. You might notice it in your app. I think how they roll out some of these features is that they'll roll it out to some states or regions or certain organizations and things like that. But there's kind of a new-ish feature out there where they'll actually integrate with the major rental car companies. In the US, you probably think of a bunch of them. And it'll basically query the local inventory for users of Uber for you as the end user to Uber. Right. So you could actually pull it up and you would see, Avis, National, Hertz, whatever it is, right? And the local inventory, and the Uber app will actually query those APIs and present that to the end user. So I was working with a customer down here, and they want to be part of this program, obviously, because we want to expose our inventory to the entire Uber user base and hopefully rent their cars and give us money, because that's really important. And that's a great, line of, it could be a good, income for us there. So they end up adding their inventory API to it, and Uber puts a line in the sand. Hey, if you don't get your inventory back to our end user within 5 seconds, we're going to forget about you, and we're going to go query the other APIs, and we're going to fill it up with the other rental car inventories, and you're going to miss out unless you get your local inventory to our end users within 5 seconds. Because Uber doesn't want to look bad, because they don't want the rental car companies to be the reason why Uber's users are having a bad experience, right? So this was a huge red flag for our rental car customer here. And they actually were noticing Uber was just saying, "Nope, sorry, we're cutting you off 5 seconds, or you're not getting this user base to sell to," right? So we were actually created an SLO for that. So basically the local inventory API for their Uber partner program there. And so they can tightly, because basically, even if their API returns a 200 response code, if that response code comes in over 5 seconds, that's counts as a failure state to them, right? So they're now counting as an SLI this as a failure if it's above 5 seconds. And it's just, I thought it was just really good use case and kind of like two worlds colliding. You have the Ubers in the Silicon Valley kind of type world that's really starting to, from day one, adopting SRE practices and performance and reliability for their end users, clashing with legacy systems and legacy organizations that don't take these performance requirements seriously and might just be sort of a checkbox, or maybe in the past and it's maybe not blame them too much, because in the past users maybe were more patient, things like that, right? So I just thought that was a really good story. I don't know, what do you guys think about that? Have you guys seen that?
I'm still fascinated, just like the first time when you told me about it.
Yeah.
And for me, the magic moment is here, and I think it clicked again when you said, for these rental car companies, in this case, this is a huge business opportunity because they're exposed to a new buyer group.
Correct.
But they can basically easily measure how many opportunities they're missing out on because they're not hitting their SLO. Exactly. Now, the only thing that I want to challenge here, or not challenge, but expand, the SLO should not only be defined on the service itself in the data center, because Uber is also measuring that performance from the mobile device. This is why I think synthetic is so important in this case. You want to set up additional synthetic checks from different points in that region, right? And whatever territory, geography that is, and then measure the performance from these locations. And also take into account, don't just test it from high-speed connections, but also do some, simulate some cellular data bad connections as well. Right?
Yeah. No, that's a great point, actually. Let me chew on that for a second, because it's one thing to measure it from the entry point of the data center, which is that what they're doing today. Obviously that needs to come in under 5 seconds, but really it honestly should be tighter than that, because these users could be using a 3G network out in the desert somewhere, or 2G or whatever, right? Whatever you get out there, satellite, Starlink, I don't know, but it'll go, you got to take account for that front end network before it even gets to the back end rental car API. So
that's why we call this. I would call this, you break down your performance budget, right? If you have 5 seconds on the top, and you know that you're on average losing 500 milliseconds on the network before it hits you, then you only have 4.5 seconds left and not 5.
Yeah, good point.
It's interesting. It sounds. My thoughts on it are more of the sort of political business impacts of it, and I'm torn on how I feel about this whole practice. If you think about some big box retailers where they say, if you don't do what we want, we're not going to put you in the store, or this kind of stuff, and they've had a major impact. But that's more of an issue of like big shark versus minnows. Whereas in this case, you're dealing like big shark versus tiger sharks, right? Both predators, both big enough and all. And you're also enforcing great performance, which is different than enforcing pricing that could destroy the minnows. It's still kind of odd though, because you have like the people at the top, or the companies at the top, enforcing a practice, and then in my head it's like, well, where do you draw the line versus a good practice, which would maybe be performance, versus something else, and how is that defined? It's not really the topic for the show, but that's really where my mind went on this, where it's like Uber saying, you're not going to get our business if you don't do this. Now, overall, in reality, the fact that it's about performance, I'm prone to say, or I fall more to the side of, well, yeah, that's good, because better performance is good for everybody. But it's just it's an odd situation where you can have companies so powerful that they can call those shots.
Yeah, but it's the same that Google did with, how they rank your page in the search result, right? Because they also factor in page load time, and therefore
right, but
rank
that's search result, but that's not direct business impact. That's abstracted.
No, I disagree here, because in the end, whether I'm searching for a ride or whether I'm searching for a piece of content, I want to find the right thing. And if I don't find it, because it's not fast enough, right? Google ranks it differently and Uber doesn't show it to me. In the end, for me, it's the same thing.
I think Brian is just against service level tyranny.
That's a good way to say it. The tyranny aspect, I think, and I'm not against the whole idea. It's just like, these are the thoughts that like going through my head, like, okay, how comfortable am I with that? And there's different components to it. But yeah, it's interesting. And I think it's a fascinating use case for sure. And as Andy said, you got to take in those other factors, like that latency on there and add that to the budget. This is, it's amazing stuff that you're running into. And this is once again why Andy and I love doing these podcasts. And I hope our listeners do too, because it's like, how often do you get to hear these stories? I just love them.
Yeah, especially too. I mean, I know everyone's, we've talked about COVID so much. Everyone's tired of it, and I'm sure. But really, I mean, it's like, especially you don't get to collaborate and talk with folks and share these types of stories as easily anymore. So it's just fantastic to be able to come on something like this and kind of share and collaborate and kind of. We're all still out there experiencing all the same things. The world kept going after all that.
Yeah. Hey, I don't want to be a party pooper for two reasons. I don't want to poop this party because I really like talk to you.
Because you only have one pair of pants.
First, correctly. But then there's also another party going on here because fortunately, as Brian, as you mentioned in the beginning, or maybe I think it was actually in the observability clinic we recorded, he said, fortunately, COVID is hopefully getting less impacting, and got some colleagues here in the office. And I fear that if I'm not fast enough, my SLO will turn red because there's no beer available anymore. The beer availability is dropping too fast. And I want to make sure I don't miss out on it. But I had to bring this in.
Priorities.
A BLO, a beer level objective, something like this, beverage level objective.
Exactly.
No, but Brian Chandler, fascinating stories. I really love it. And I have one more comment because I recently heard this on the meetup. We talk a lot about legacy code, but I heard a different term. Legacy code is just code with character.
Yes.
Yeah, it's still code. Just don't call it legacy. It's code.
It's big boned.
It's big boned,
yeah. It's got scars and opinions. And
exactly.
Yeah.
All right. Well, Brian Chandler, it was amazing having you on. I hope we can have you back and bring more stories.
Absolutely.
And you have a microphone.
That's right.
It's fantastic.
Yeah.
Any closing thoughts, Brian?
I think that's it. Again, thanks for having me on. I really appreciate it. Follow me on Twitter. It's Channer531, CHANNER 531. And check me out. I'd love to talk about performance stuff. So thanks again, guys.
I think we'll put the link in the proceedings because there was a really complicated Twitter handle.
I'm just trying to keep everyone on their toes,
Yeah.
And
only highly intelligent people that can listen to spelling can have the right to follow me on Twitter.
Well, hopefully they're all taking notes. I'm going to start calling you Channer, but your new name to me is Channer now.
Exactly. Yeah.
All right. Well, thanks everyone for listening. I hope you all found this helpful and informative. If you'd like to leave a comment, you can do so at pure_DT at Twitter. Any show ideas, you can send us an email also at pureperformance@dynatrace.com. Thank you, everybody. Thank you, everybody, for listening, I should say, instead of getting the marbles in my mouth. All right. Take care, everyone. Bye-bye.
Bye-bye.